So today we're going to put all the pieces together that we've been learning about quadratics, and we're going to kind of talk about, well, how do I apply this? How would I use this information? So very quickly, let's kind of talk about the graph here of a quadratic. So this is, notice, one that opens downwards, and it's got a few points here that I want to just label with you. So remember our maximum point here, the name that we call that is the vertex. Here where the line or the graph intersects the y-axis is called the y-intercept. And then here where it crosses the x-axis, these are both examples of an x-intercept. Okay, so those are both x-intercepts. So as we start talking through, quadratic application questions, and using this information, a lot of the problems that we're going to come across have to do with throwing an object off of a building or kicking a ball from the ground, or something like that. And if you think about those things, when we throw something or when it's kicked, that object generally has a parabola or an arc-type shape where it goes up, it hits a highest point, and then it makes its way back down. And so these notes are meant to help you when you come across a question like those, just kind of pointing you in the direction of, well, what if you get a question that's asked in this manner? What are we really looking for? What are we talking about? So one of the things that we want to keep in mind is that when we're talking about a quadratic application question, something about, kicking a ball or throwing something, usually in these cases, the x-axis is going to represent time that's passing. That's our independent variable. It's something that I can't control. It's something that is kind of independent of anything that I can do. So it's my x-axis here. Now the y-axis is generally is your dependent variable. It's representing the distance from the ground. Most of the time when we have a question like this, it's representing how far something is from the ground, and that's something that it's dependent on the time. It depends on when you threw the ball and how fast it was going, and several different factors, and it's dependent on this idea of time. And so you want to be careful when you work through these to make sure that you pay attention to the units. Make sure that your units are matching all along the way. Sometimes they like to throw a little bit of a conversion in there on a question in addition to what you're doing. So just pay attention that your units are always in the same as well. You've got usually a time and some kind of distance or height that's going to be another representation there. All right, so a couple of things that you may come across. So x-intercepts. Another name for them, remember we had a couple of different names for these, but when we're talking about an x-intercept, we're also talking about solutions to a quadratic, or we're talking about roots, or we're talking about zeros. And we've talked about how to solve those, that you have a few different methods. You can factor, you can graph, you can use a quadratic formula. But when we're talking about it in terms of this idea and the application questions, the point here at the x-intercept is the point where y is 0. It's the point where the distance from the ground, that y representation, the distance from the ground, is 0. So it's generally going to be where that item, that object, has hit the ground now. It's the time where that item has has met the ground, or is at a y value of 0. And that's what an x-intercept is. It has some x value, but the y value is always 0. Whereas with a y-intercept, your x value is always 0, and you have some y value there. So these x-intercepts, remember, are going to be where your y is 0. It's where whatever item it is has hit the ground. That object has now come back to the ground level. Okay, so you'll notice here that there are two intercepts here. One is to the left of the origin, one is to the right. And this is, again, a generalization. A lot of times this is what you're going to see on a question like this. Not always, but a lot of times. So you'll notice there's a negative x-intercept and there's going to be a positive y-intercept. So a negative number for your solution and a positive number for your solution. And we notice that a lot of times we do have two solutions, and a lot of times one is negative and one is positive. Not always, but a lot of times. So in this case, the negative x-intercept is generally going to be thrown out because we're talking about time here. And the time before the start of our launch of our item doesn't matter to us, or negative time doesn't really exist. We can't talk about negative time. And so we consider that to be not a viable solution in most situations. And so we throw this item out. And so when we talk about an x-intercept for a problem like this, we're generally talking about just the positive x-intercept. And it represents what time did the object hit the ground. Okay. Now, so this would be something like if you're asked a question like, when did the object hit the ground? Or how long was the object in the air? Those are questions where they are asking you to look for that positive x-intercept. They want to know, when did it hit the ground? Okay, well, the ground means that the y value has to be 0. Well, that means that I'm looking for an x-intercept here. I want to know at what time that happened. Or if it's asking you how long was the object in the air, well, it's in the air up until the time that it touches the ground. So we're again looking for this 0 and time passing. What time did it hit that? That's all the time that it's in the air from 0 to that point. So again, we're looking for the positive x-intercept there. All right, so those are some ideas, some things that you might see. Also, you may be asked the question, something like, how far off the ground is the object after such and such time? So let's say that we want to know how far off the ground is the object at this time right here, whatever time that is. Well, to find that, I'm given the time. So I want to know at what point on this parabola is my object. Well, if the x value is this, then all I need to know is what's the y value that corresponds that puts it on that graph. So in that case, I'm going to plug into the equation the given time for x, and I'm going to solve for y. And again, be careful that your units match. Make sure they didn't try to trip you up by giving you a different unit and you need to do a conversion. Okay? All right, other question you might see. Question like, at what time is the object blank meters off the ground or feet off the ground or whatever distance or height that you're using? So in this case, we're told, well, I want to know when is my object this far off the ground. I want to know when is it 20 feet or 20 meters off the ground. And that happens right here. Well, I need to know what the corresponding time is. So in this case, they're giving me a y value. They're giving me a height or a distance. I need to know what's the x value. So we're going to plug the given y value into the equation and solve for x. And so those are the types of questions that you're going to be plugging values in and just evaluating those, simplifying those equations. Okay? All right. Now, a couple other questions. We come across the y-intercept. So remember that the y-intercept represents, again, where that x value is 0. Well, in this case, that means where time is 0, meaning at the very start of this, before anything is thrown, before anything is launched, before anything is kicked, before anything happens, how high is that object off the ground? Well, it may be starting from ground level, so you may have a parabola that looks something much lower down here, or it may be starting from 20 stories off the ground, or it may be starting from 10 feet off the ground, or whatever the case may be. It has a height that it starts at, and that's what we're asking for when we're looking for a y-intercept. So the y-intercept represents where time is 0. Where are we at our starting point, our initial time before anything happens? Where is this item located? This is the distance the object is from the ground before it is released. It's that distance away. Now, what if you're asked a question like, how far off the ground was the object when it was released? Okay? So I want to know when I first let go of it, how far was it? Well, before I let go of it, the time was 0. so I can look at the y-intercept to tell me how far it was off the ground before it was relieved. So we would be looking for the y-intercept in a question like this. All right, a couple more questions. So this time, we remember that the vertex is the time that the object reaches its maximum height. Okay, so that's my tallest point up here. There's always a point where an item reaches this upward point, and then it starts to fall. So in this case, if you're asked a question like, how long did it take the object to reach its maximum height? Well, I'm looking for the time that it took to do that. Well, time is my x value of that vertex. That's what I'm going to be looking for. And then we have the question, well, what was the maximum height of the object? How high did it get? Well, again, we're looking for the vertex, but this time I want to know what the y value is, what the height was. So I'll be looking specifically for the y value there. So hopefully they just kind of help you kind of put all the pieces together and see kind of what we have and what we use with some of the wording and the questions and things like that. So hopefully these notes will help you just a little bit on that.